All right, an inverse function is actually a reflection over the line y equals x. So if you graphed a line y equals x, it should look like it's a mirror image over that. So what it really does is it switches your x and y, since that's what you're flipping over. So all of the numbers here, the inverse would be 3, 2, 5, 4, 1, 1 stays on the graph. If you graph these, you would see that they were a reflection. So if I go this, and here's your line y equals x, see, it should look like it reflected over that line right there. So if I do like 2, 3, and 3, 2. See how it looks like it's a reflection over that line. So that's what it is. So in order to solve these algebraically, you're going to switch your x and y and just resolve the y. So resolve it for y. So switch your x and y, and I'll get y by itself. So add your 4 over. I'm going to divide everything by a 2. So I get 1/2 x plus 2. And you'll usually see f -1 of x. That means it's the inverse function. So how do you distinguish between the two of them? This would be called f of x, and then the answer is called f inverse of x. So that means inverse when you see it. So switch your x and y, and now resolve it. So you have to subtract 6 from both sides and divide everything by a -3. -6 divided by -3 is a positive number. So go ahead and try 3 and 4 on your own. Instead of dividing by 1/3, I'm going to multiply by 3 over here. So instead of dividing by a fraction, you multiply it by its reciprocal. So get rid of a power of 7. You should 7th root both sides. So that's the inverse. All right, some of these get a little bit trickier. So down here, to get rid of the cube first, we got to cube root both sides. And I'm going to subtract my 1. Make sure it doesn't look like the 1 is underneath the radical. Make sure it's clearly outside or put it in front. Get rid of cube root. We're going to cube both sides. And then add your 6 over. All right, this one gets a little tricky. I like these a lot. So switch your x and y here first. Whenever one side's a fraction and one's not, you make them both fractions, and it's an equal sign here, so that's why I'm allowed to cross multiply these. So I'm going to do x to both of those terms. So it's like x times y minus 3. I'm going to go ahead and multiply that in. When you multiply this side by 1, it doesn't change it. Now I need y's on one side and the x's on the other. So I'm going to add my 3x and subtract my y. These are not like terms, you guys. An xy and a y are not like each other. So what you do instead is you factor out the y. That's how you get the y by itself. And then I'm going to divide it over. Okay. So same thing here. Switch your x and y. Cross multiply them. I'm going to move my 5x over and my 3y over. Factor out your y here. And then I'm going to divide by x minus 3. All right. So what happens when we are sometimes finding some inverses and we square root both sides or 4th root it, you're going to get a plus or minus. So what happens is that a plus or minus tells you that the inverse is not a function. So if you have plus or minus, the inverse is not a function. So right here, I'm going to show you. So if I switch the x and y here, I get x equals y squared. I have to square root it, and these were cube roots up here. That's why it didn't matter. So when I square root it, I'm going to get square root, and I get plus or minus. This means it is not a function. So you can have an inverse, it's just not a function. So what typically happens is that you'll see a domain back here saying like x is greater than 0. That would mean you'd keep the positive square root. Or if it said x was less than 0, then you'd keep the negative square root on the problem. But since it said neither of these, it's just not a function. So you can restrict the domain to make it a function. Let's see if this one's a function. So to get rid of a square root, I should square both sides. And then I should add my 5 over. So here's the inverse. The problem is that this was only defined for 5 and bigger. That means that this is only defined for 5 and bigger. Okay, you can't switch this would be 0 and bigger. Sorry, the domain becomes a range. This was the domain. The range is 0 to infinity. So that's the range. So now the domain is 0 to infinity. You see how that plus 5 would change it to the range? So that's a 0. So it's really only going to be half your parabola. But it is a function. So when you square root both sides, you got to put a plus or minus and then bring your 1 over. Since it says plus or minus, this is not a function. One fraction and one's not, you cross multiply them, make them both fractions. I'm going to divide by my x. And then I got a 4th root to get rid of that. 4th root, don't forget, it's an even root. So I got to put my plus and minus in front of it. Plus and minus means not a function. So if you have not yet paused me to try some on your own, now's a good time to pause, try them on your own, and then come back and see if your answers match mine. This is not a function because it became plus and minus down here. So I subtracted my 5, divided my 3, and then square rooted to get rid of the square right there. This time you gotta get rid of the square first because it's on the outside of the parenthesis, and that's not a function because it's plus or minus. I forgot to switch my x and y. Remember, the range on this one was 0 to infinity, so the domain on the inverse, you switched them, is going to be that same thing. To subtract your 3, I'm going to divide by -1, which changes all the signs, and then square root. Plus or minus means it's not a function.